You've definitely heard the term data science thrown around. It's become this huge buzzword, and for good reason. It's a field that is quietly, but fundamentally, reshaping our world, from the stuff you buy online to the news you see. But what does it actually mean? What is data science? Well, let's break it down. Okay, so a lot of the hype really kicked into high gear with this one now famous quote. Back in 2012, the Harvard Business Review made this super bold claim, and boom, suddenly everyone wanted to know what a data scientist was. But sexy? What's so sexy about data? What's really going on behind all that hype?
And that's the big question, right? It sounds incredibly important, but what does a data scientist actually do all day? It can feel like a bit of a mystery. So that's what we're going to do here. We're going to pull back the curtain and really get a look at what's going on.
So let's start with a solid, basic definition. At its absolute core, data science is all about finding the story, finding the knowledge, finding those little hidden insights that are buried inside raw data. You can almost think of it as part detective, part storyteller, and part scientist, all rolled into one. To really get a handle on what data science is, it's actually super helpful to think of it not as just one thing, but more like a recipe. And like any good recipe, it's got a few absolutely essential ingredients. So let's break down what actually goes into the mix.
And here they are. These are the 3 pillars of data science. You need the solid foundation of math, the raw power of computing, and, just as important, the real-world context that comes from expertise. Seriously, if you take any one of these away, the whole thing just kind of falls apart.
All right, ingredient number 1, math and statistics. This is the absolute bedrock. It gives you the rules, the theory that lets a data scientist build models you can actually trust. It helps them figure out if the results are real or just random noise, and it lets them put a number on the maybe in any prediction. Next up, you need the engine to make it all run, and that's computer science. I mean, the amount of data we're dealing with today is just staggering. You can't analyze this stuff with a pencil and paper anymore, right? This is where programming languages, usually something like Python or R, become the power tools you need to wrangle these massive data sets.
And that brings us to the third, and maybe the most underrated, but absolutely crucial ingredient, domain expertise. Look, you can be the best programmer and the best statistician in the world, but if you don't get the context, whether that's finance or healthcare or online retail, you're not going to know what questions are even worth asking. Or, just as bad, you won't understand what the answers actually mean in the real world.
And this is where the magic happens. It's right there, at the intersection of all 3 of these skills. It's not about having them in separate boxes, it's about blending them together. A statistician knows stats, a programmer knows code, a business expert knows the business, but a true data scientist is the person who can stand in the middle and bring it all together.
Okay, so we've got our ingredients. Now, what's the actual recipe? What is that step-by-step process of turning some vague business problem into a genuinely valuable insight actually look like?
Well, it generally follows a kind of life cycle, like this. It all starts with framing a really clear, specific question. Then comes the grunt work, honestly, cleaning and preparing the data. After that, you get to the cool part, building and testing a model. And finally, you actually deploy it. You put it out into the world so it can start doing its job. It's this whole journey from problem to solution.
Now, of all those steps we just walked through, which one do you think eats up the most time? You'd probably guess it's the modeling part, right? With all the cool, complex algorithms. Nope. The reality is most data scientists spend a staggering 50 to 80% of their time just cleaning and preparing data. It is not glamorous, but it is the absolute foundation for everything that follows. So, this all sounds great in theory, but where does the rubber actually meet the road? Let's talk about a few examples of how data science is already shaping your daily life, probably in ways you don't even realize.
You know when you're on a shopping website and it feels like it's reading your mind, recommending the exact thing you were just thinking about? Yeah, that's data science. Those recommendation engines are analyzing your clicks, what you've bought before, and what millions of other people like you have bought to make these spookily accurate suggestions. Or how about this one? You get that instant text from your bank that says, "Hey, did you just spend $500 on rubber chickens?" That alert is a data science model. It's learned your normal spending habits, and it instantly flagged something that looked weird, protecting you from fraud in a matter of milliseconds.
And look, the impact here goes way beyond just shopping and security. In healthcare, data science models can sift through mountains of patient data to predict who's at a high risk for really serious conditions. This means doctors can step in way earlier, which can and does literally save lives. So it's pretty clear this stuff is incredibly powerful, right? But with great power, well, you know the line, comes great responsibility. So for this last part, we have to look at the other side of that coin. We have to talk about the risks and the very real ethical challenges of data science.
And this gets to a fundamental tension at the heart of the whole field. On the one hand, you've got this incredible promise to solve huge problems, drive innovation, create amazing value. But on the other hand, you have the perils. The models can sometimes be total black boxes, where we don't even know how they're making decisions. They can pick up and even amplify the biases that are already in our society. And they raise these huge ethical questions about fairness, privacy, and accountability.
And that right there is really the key takeaway I want to leave you with. As this field keeps getting more and more powerful, the biggest challenges aren't going to be technical. They're going to be human. The most important question isn't just what we can find out with all this data, it's what we should do with that knowledge. It's about having the wisdom to guide this incredible power responsibly. Thanks for joining me for this explainer.